Hey guys, welcome back to another lecture video for Chem 104. In this lecture video, we are going to cover how to name alcohols that's found on benzene rings. So if you guys recall from chapter 11, benzene ring is one type of one molecule that demonstrates an aromatic compound. There's many others. Now, the nomenclature, the naming of alcohols and benzene rings has already been done. We've already done it in chapter 11. Hopefully by highlighting this word phenol, it kind of drums up that concept that we covered in the previous chapter. But we'll still go ahead and go through the basics to make sure that you guys remember how to name organic compounds that contains an alcohol in a benzene ring. So looking at some of the key rules here, this hydroxyl, this alcohol, is automatically on carbon number 1 on a benzene ring, very similar to that of cyclic alcohols. And so for anything that's cyclic, whether or not it's a benzene ring or just a regular cyclic alkane or alkene, this hydroxyl group is always going to be on carbon number 1. So wherever that hydroxyl group is, whatever carbon it's bonded to, that carbon is super lucky because it gets carbon number 1. And so all we have to do is just figure out a numbering system such that the substituents is going to have the lowest carbon number possible. And so whenever you guys see this alcohol with this benzene ring, this whole entire entity that I'm circling in blue is called a phenol. And so that's going to be the parent name of this benzene with an alcohol. And so I'm just going to go ahead and highlight it in pink. So all of this with all of this, that's going to be our phenol. And so please, please, please be very careful. I've seen it happen in past semesters where students name this as a cyclohexane or cyclohexene or a cyclotriene or something like that. Just keep in mind that when you have this repetitive conjugation, this double single bond, and if there's 6 carbons and it forms a ring, then that's going to be your benzene ring. Okay. If it's outside of those conditions that I've mentioned, then it's probably going to be named in a different way, and you guys cannot use phenol. Okay. So part of this is just out of like pattern recognition. For this very simple example, I'm just going to erase this for clarity. So since the hydroxyl group is attached to this carbon gets carbon number 1. And so the carbon right next to it has another substituent, and so that's going to be carbon number 2. And now if you guys go counterclockwise, you'll get carbon 6 for methyl, which is a very high number for a substituent when there is another path that can produce a lower value for the methyl group that's covalently bonded to the carbon. And so here in this case, we're just going to go ahead and describe this as 2-methyl. And so here we have 2-methyl phenol. Here, since this is carbon number 1, and here once again we have that phenol, the only thing that we need to do is just describe the carbon number on this methyl group. And so if you guys go clockwise versus counterclockwise, you'll find that you'll get a lower number if you number it clockwise in this example. And so here in this case is going to be carbon number 2, carbon number 3. And so just to demonstrate it for you, if I do it counterclockwise, this is carbon 1, 2, 3, 4, 5, right? So notice that 3 is a lower number than 5, so therefore the numbering system going counterclockwise is incorrect. And so overall we're going to get 3-methyl phenol. Okay. And so the answer to the last one is going to be 4-methyl phenol. And we're done. Okay. And so let's go ahead and look at both of these two structures. So once again, we have this hydroxyl that's covalently bonded to this benzene ring. And so I know that wherever this hydroxyl group is covalently bonded to the carbon, that's going to be carbon number 1. And since there's only one substituent, you want to number your carbon system so that your next substituent is going to have the lower carbon number. So in other words, carbon number 2. And so notice that I have 1, 2 carbons. And so since this is a 2 carbon substituent, this is going to be an ethyl. So putting these pieces together, I'm going to write 2-ethyl and then phenol. So let's go ahead and take a look at the next example. Once again, I see my phenol right here. And I know this is carbon number 1. And so notice how this molecule, if I were to like cut it in half, looks very symmetrical. And so if you guys fall upon that situation, then that tells you that your numbering system is going to be the same if your substituents are symmetrical with respect to each other. So in this case, it doesn't matter if you do it clockwise or counterclockwise. So I'll just do it counterclockwise just because. 1, 2, 3, 4, 5, 6. Now if you guys do it clockwise, you will find the same numbering system applies. And so for this example, since I have a phenol, I'm just going to go ahead and write my parent name down. And I have 3 chlorine groups. And so I have chlorine on the 2nd carbon, the 6th carbon, and the 4th carbon. So what I'm going to do is I'm going to combine all of these chlorines together, and I'm going to say 2, 4, 6 dash trichloro. Okay. And since this is a letter to a letter, I'm going to go ahead and just combine both of these words into one word. So this is 2, 4, 6 dash trichlorophenol. All right. And so hopefully by going through these simple examples, it kind of refreshes your memory on how to name alcohols on benzene rings. Okay, so just keep in mind that the root name that you're going to be using is a phenol. So let's go ahead and look at some more complex structures here. So we'll do about a couple for this example. The rest you guys can probably do on your own. So I'm going to look at F and H. The reason why I'm looking at F and K. The reason why I'm going to look at F and K is because it contains a double bond and an alcohol. So I just want to go through and make sure that you guys understand the process on how to name these types of organic compounds. And so here I have a cyclo. I have a cyclic alcohol for F. So I'll just write it down. So I have a cyclic alcohol. And so that tells me that wherever that alcohol is, that's going to be carbon number 1. And now I just need to figure out my numbering system. And so if I go clockwise, I get 1, 2, 3, 4, 5, 6. If I go counterclockwise, I have 1, 2, 3, 4, 5. 5, 6. And so if you guys are looking at the numbering system, here I have in blue, so I'm going to go, so this is going to be clockwise. So I have something on 2, and I have something on 5. Okay. If I go counterclockwise, I have something on 3, and then I have something on 5. So my double bond starts at 5. Okay. And so in this case, counterclockwise is probably not favorable, just because we'll get a higher number in one of those values. And so it looks like my numbering system going clockwise is correct. And so for this cyclic alcohol, I know I'm going to be using 2 and 5 to describe my double bond and my chlorine. And so let's go ahead and talk about the parent name. So I think I just moved steps. I just jumped some steps. So let's go ahead and focus on the name now that we have the numbering system down. And you guys can go either or, doesn't really matter. And so here in this case, I have 6 carbons. So since I have a 6 carbon compound and it's cyclic, I'm going to say cyclo hex. Okay. And the moment I see a double bond, I know I'm going to put in ene as my ending, not ane. And so I'm going to go ahead and erase the E, and I'm going to add the OL. Since this is a cyclic compound, I don't need to indicate. I'm going to omit that 1 on the alcohol for cyclic alcohols. But I need to tell the reader what carbon number my double bond starts. And so that can be demonstrated by putting a number right in front of cyclo. So this is going to be on carbon 2. So on carbon 2, that's where my double bond starts. And so the last thing that I need to identify here is the position of my chlorine. And so on the 5th carbon, it looks like I have a chlorine group. And so I'm going to say 5 chloro, dash 2 cyclohexenol. Just going to touch up just a little bit. All right. And so here, this is going to be the name of this organic compound, 5-chloro-2-cyclohexenol. And so I started performing this clockwise, counterclockwise scheme because I have, all these different substituents. I have double bond, I have, chlorine group and all that stuff. And so as long as you guys are getting into the habit of doing this, then you guys should be able to, like number your carbons correctly. And so you guys are just simply listing down the locants, the carbon numbers, and you're just seeing which one is the least combinations, right? Okay, and so let's look at K. So K is not acyclic, so this is acyclic. No, I'll just put a not cyclic. So not a cyclic alcohol. So here's my alcohol, and it's not cyclic, it's a straight chain. And so what that tells me is that I need to number my my longest carbon chain such that the alcohol gets the lowest number. Okay, so let's first figure out what my carbon chain is. So I have 1, 2, 3, 4, 5, 6, 7, 8. And so here in this case, I have oc. So notice how I'm not putting cyclo, right? I'm not saying cyclo-oct because it's a straight chain. So this is going to be an octane. Okay, so 8 carbons. But before I ink that, notice that there's a double bond. And so it's not going to be octane, it's going to be octene. But before I ink that in, notice that there's an alcohol. So it's not octene, it's going to be octenol. Okay? And so hopefully you guys are, you guys understand my rationale for erasing and then rewriting and then erasing and rewriting. I'm kind of like, using my knowledge from all the different rules and just building it on until I'm describing my double bonds and my alcohols correctly. Now, since this is not a cyclic alcohol, I have to describe the carbon number for the double bond and the carbon number for the alcohol. So I need to figure out a numbering system. So this is where you're going to do the left to right, right to left. 1, 2, 3, 4, 5, 6, 7, 8. Right to left, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. And so all I'm going to do is just summarize all of the substituents that I see and make sure that my alcohol gets the lowest number. And so if you guys are looking at the scheme in green, I have a 3 on the alcohol. However, if you guys are looking at the numbering scheme in blue, 6 is on the alcohol. Okay? And so this tells me that the blue numbering system going from left to right is probably incorrect. So our alcohols get the priority. And so since I have a mixture of an alcohol and a double bond, I need to separate these two. And I'm going to now describe that my alcohol is on carbon 3. And I am going to communicate to the reader that my double bond is going to be on carbon 5. Okay. And so as I'm going from left to right, boom, I hit carbon 3. There's my alcohol. As I go from, I'm sorry, not left to right. As I go from right to left, I hit my alcohol. Right to left, I hit my carbon that in which my double bond is going to start. Okay. And then as I'm continuing, I hit this bromine that's on carbon 7, so 7 bromo. And so I'm going to place this in front of my parent chain, so there's going to be 7 dash bromo dash 5 octen dash 3 dash all. Okay, and so I want you guys to notice the differences between something that's not cyclic with a double bond and something that is cyclic with a double bond. All right. And so I want to go ahead and go over just one more problem in this list here, or in this slide. So I want you guys to notice that on letter L, there is a double bond, a triple bond, and an alcohol. So we have all three that's on this compound. Let me zoom in. Okay. And so how do we name a substance that has all three of these key features, the triple bond and alcohol and double bond? Well, let's just take it step by step. The first thing that we need to do is figure out the number of carbons. So this is 1. Remember, the tail end of a triple bond, that's a carbon. The other tail end of that triple bond is another carbon. So that's 1, 2, 3, 4, 5, 6, 7. And so it looks like my parent name is, it will involve hept, right? So 7 carbons. Okay. And so I need to figure out my numbering scheme such that I will get a lower number for my alcohol. So let's go left, right, right, left. So 1, 2, 3, 4, 5, 6, 7. So if I go right, left, right to the left, 1, 2, 3, 4, 5, 6, 7. So if I'm looking at my numbering system on the alcohol, notice that it's 4 and 4. Okay, so it's a tie. So whenever you guys have a tie, you're going to go ahead and look at your double bond. And so if you have a tie in your alcohol, then you want to make sure that the double bond has the lower carbon number than your triple bond. And so if you look at the numbering scheme here, we have carbon number 1. So carbon number 1 is where my double bond will start. Carbon number 6 is where my double bond will start. And so in this scenario, you would want to choose the green numbering system because it's going to provide us a lower carbon number for the double bond. Okay. So here in this case, the priority is alcohol, then double bond, and finally triple bond. Okay. All right, so now that we've figured out our numbering system, let's go ahead and erase the ones that's incorrect. So what this is telling me is that I have a double bond that starts at carbon number 1, an alcohol that's found on carbon number 4, and I have a triple bond that starts on carbon number 5. and I have a 7-carbon chain. And so let's go ahead and name this. So first of all, since I have a double bond, I'm going to put in heptene. And then since I have an alcohol, this transformed into an ol. However, since I have a triple bond, I need to go ahead and wedge these two. Like I'm going to separate these two to include the triple bond, which is a yne. So Y N E and then O L. Okay. And so for carbon number, for the double bond, the En, that's on carbon 1. So I'm going to put 1 hep10 to describe the location of the triple bond, or not so much location, but where it starts. It's going to start on carbon number 5. Oops. So I'm going to put -5 yne. And so the triple bond starts on carbon 5. And for the alcohol, I'm going to put -4. Okay, so that's where the alcohol is located. So this is going to be 1-hep10-5-yne yne -4-ol. Okay. So this would be the name of this substance. Okay. Kind of complex. All right. Last example that I want to go over is H. And so here we have 2 OH groups. So how do you name a substance that has two OH groups? Well, let's go ahead and start by figuring out our longest carbon chain. So this is 1, 2, 3, 4, 5. Okay, so that's 5. If I go back 2 spaces, 1, 2, 3, 4, 5, 6. If I go back 1 space, 5, 6, 7. And so it looks like 7 is the longest carbon chain. And I'm going to go ahead and start numbering this left to right, right to left. So 1, 2, 3, 4, 4, 5, 6, 7. If I do it in reverse, 1, 2, 3, 4, 5, 6, 7. All right. And so I'm going to choose a numbering system so that my alcohols have the lowest numbering set. And so if I go from right to left, which is in green, notice that I have an alcohol on carbon 2, and I have an alcohol on carbon 5. So I have 2, 5. And so if I look at my numbering system in blue, going from left to right, I have an alcohol on carbon 3, and I have another alcohol on carbon 6. And so it looks like this numbering system is incorrect, the one in blue, just because it has a higher value than if we go from right to left. Okay. So I'm going to go ahead and erase all of this. And I'm going to keep my numbering system in green. So since I have a 7-carbon chain, I know that I have to use the prefix hept. And since I have 2 alcohols, actually, let me take that back. Let me not so much take it back, but let me go back 1 step. So I have a 7-carbon chain, so that's hept. Now, if you look at the whole entire chain, there's no double bond, no triple bond. And so I'm going to finish this by saying ane. Now, if you guys look, I have alcohols that's present. And so I'm going to erase the E, keep the N, erase the E, and put in all. Heptanol. But since there's two alcohols, I need to erase the all and say heptanediol. Right? So there are two alcohols. And so what you want to do is you want to describe or tell the reader the position of where those alcohols are located. And so since I don't have a double bond, if I don't have since I don't have a double bond or a triple bond, then that means that those numbers, these locants, 2 and 5, is going to be located in front of heptan. So it's going to be 2, 5 dash heptanediol. Okay, so once again, these two alcohols are located on carbon 2 and on carbon 5. So now that I have the parent chain completely named, I'm going to go ahead and look at my substituents. And so I have a 3-methyl. It's a 1-carbon substituent. 1, 2, so that's a 2-carbon substituent. So that's going to be 5-ethyl. Since I have two different substituents, I need to order them alphabetically. So this is M, this is E. E goes first. So therefore, my name of this compound is going to be 5-ethyl. Next is going to be the 3-methyl. And then I'm going to go ahead and conclude the substituents by describing the name, the parent chain. So this is going to be 2, 5 dash heptanediol. All right. And so this is how you would tackle naming an organic compound if there are more than one alcohols. Now, if there's 3, you say triol, and you would describe the locants or the carbon numbers of where all of those alcohols are located. And if it's 4 alcohols, then you would say tetraol or tetrol. Okay. So hopefully by going through these more complicated organic compounds, you guys have a better feel of how to name them. All right, and so that's it for this lecture video. The next video, I believe we're going to go over reactions for alcohols. All right, I'll see you in the next lecture video. Bye.